and then we must write the signal type of the system, and then we write and as a keyword and entity name. Okay, for entity declaration, here we have an example. For example, we have a full adder with 3 inputs A, B, and C in, and 2 outputs S and C out. And the name of entity is full adder. Then we can write entity as keyword, full adder as the entity name, is as another keyword. Now we must write port and then the inputs and outputs. We can see that A, B, and C in are the same. All of them are input and all of them are 1 bit. Then we can write all of them in one line, A and B and C in signal mode. They are inputs and we must write in. Bit, it is signal type. All of them are 1 bit line. S and C out, both of them are output. Out and bit. Out at signal mode and bit at signal type. And then end full adder. It is really the entity of the circuit. It is how to write the entity declaration. We can have another example here. For example, entity of the D flip-flop entity, DFF, is port. D and clock and RST, it means reset. All of them are input. And for signal type, we write STD logic. It means standard logic. Standard logic is a special logic that IEEE write it for the VHDL coders and designers. For simulation goals, we can have some other values. If we write bit, we can only have 2 values, 0, 1. But for some simulation goals, we can have some different values. For example, undefined values, unknown values, weak high and weak low values, or maybe don't care values. These values can't be implemented on FPGA, but they can be useful in simulation. Then standard logic is another type of signal that uses for simulation and nowadays is very famous for VHDL designers and coders. Okay, here we can write STD logic instead of bit. Then we can write D, clock, RST, it means reset, in, input, signal mode, and standard logic as signal type. And another line is about Q. Q is out and standard logic 2, and then end DFF. Okay. Let me to change my slide at first. We can continue our speaking in this new lecture, the third lecture or the third slide about definition of entity. Some examples for entity definition. Another example is a multiplexer. This multiplexer is 2 to 1. It means that it has 2 inputs for selection, for example A and B, or 1 and 0, and one another input for as selection signal or selection input, and we can write it as the name of this input as S or select, and one output Z, for example. Z is A if select is 0, and Z will be B if select will be or is 1.